we'll make it clear. TriGoLearn is always here. It's tricktastic, let's explore. SOH-CAH-TOA and so much more. From sine to cosine, we'll never fear. With TriGoLearn, the path is near.
Have you ever looked at a really tall tree and wondered, how can I measure its height without climbing it? It sounds impossible, right? But with trigonometry, you actually can. By using angles and a bit of clever math, you can find the height of the tree and live in a building while standing safely on the ground. That's the power of trigonometry. It helps us measure things that seem unreachable. Engineers use it to design bridges, pilots use it to calculate flight paths, and even photographers use it to get the perfect angle for a shot. Now, you might be wondering, how exactly does trigonometry make that possible? Well, before we dive into how it works in real-life situations, let us first understand what trigonometry really is. Trigonometry is a branch of mathematics that studies the relationship between angles and sides of a triangle, particularly the right triangle. It helps us understand how these sides and angles are connected. And this connection is what makes real-life application possible. Let's begin with the most important triangle in trigonometry, the right triangle. A right triangle is a triangle with one angle equal to 90 degrees. We'll label its sides like this. The longest side is the hypotenuse. The side across from the angle we are studying is the opposite side. The side next to the angle is the adjacent side. Understanding this is very important because the trigonometric ratios are based on these sides.
Hello, Triggies! Now that you know what is trigonometry, are you ready to unlock one of the coolest secrets of it? Let us meet the three main trigonometric ratios that will help us measure the hidden connection between sides and angles of a right triangle. For us to easily remember, mathematicians create a catchy little phrase. Our magic spell for triangles, SOH-CAH-TOA. Here's what it means. SOH is for sine is equal to opposite over hypotenuse. CAH is for cosine is equal to adjacent over hypotenuse. And TOA is for tangent is equal to opposite over adjacent. Pretty cool, right? With SOH-CAH-TOA in your mind, you can easily uncover missing sides, find the hidden angles, and even solve real-world problems, even without climbing a single tree or ladder. So next time, when you see a right triangle, don't panic. Just whisper our magic phrase, SOH-CAH-TOA, and let trigonometry works its magic.
Suppose we have a right triangle with an angle theta. The opposite side is 3, the adjacent side is 4, and the hypotenuse is 5. To answer this, we're going to use our magic phrase, which is the SOH-CAH-TOA. Let us first know our sine theta. And we are going to use SOH, which is sine is equal to opposite over hypotenuse. Our opposite side is equal to 3 and our hypotenuse is equal to 5. If we are going to divide 3 by 5, the answer is 0.6. Thus, our sine theta is equal to 0.6. Next is the cosine theta. To get cosine theta, we are going to use CAH, which is cosine is equal to adjacent over hypotenuse. Our adjacent side is equal to 4 and our hypotenuse is equal to 5. If we are going to divide 4 by 5, the answer would be 0.8. Thus, our cosine theta is equal to 0.8. Next, we are going to get our tangent theta. To get this, we are going to use TOA, which is tangent is equal to opposite over adjacent. our opposite side is equal to 3 and our adjacent side is equal to 4. If we are going to divide 3 by 4, the answer would be 0.75. Thus, our tangent theta is equal to 0.75. Let's use another right triangle with sides 8, 15, and 17. The hypotenuse side is 17. For an angle theta, the opposite side is 8 and the adjacent side is 15. Again, we are going to use our magic phrase SOH-CAH-TOA. Let us first know our sine theta. And we are going to use SO, which is sine is equal to opposite over hypotenuse. Our opposite side is equal to 8 and our hypotenuse side is equal to 17. If we are going to divide 8 by 17, the answer would be 0.5. Therefore, our sine theta is equal to 0.5. Next is our cosine theta. And we are going to use CAH, which is cosine is equal to adjacent over hypotenuse. Our adjacent side is equal to 15 and our hypotenuse is equal to 17. If we are going to divide 15 by 17, we can get 0.9. Therefore, our cosine theta is equal to 0.9. Lastly, our tangent theta. Again, we are going to use TOA, which is tangent is equal to opposite over adjacent. Our opposite side is equal to 8 and our adjacent side is equal to 15. If we are going to divide 8 by 15, the answer would be 0.5. Therefore, our tangent theta is equal to 0.5. See? SOH-CAH-TOA helps us quickly find the ratios of the sides.